Let's take a look at this beam problem here. So I'm going to start off by drawing myself a line which represents the beam itself, and I'm going to go ahead and place in the fixed point, the friction-free point, and here I'm going to start adding in the human, so that's the force there. You can kind of think about it, this point here is going to react on a force going up, and this pin is going to try and hold it down. The distance between these is 1.5 meters, and between these is 3 meters. So we'll call this reaction right, or force right. This one will be force left. This is 890 newtons. So let's start by, this one here is our free body diagram basically. Now let's start by finding out the reaction forces. So you have three equations. You have the sum of all forces in the x direction must equal 0. The sum of the force in the y direction must equal, and the sum of the moments must equal. So if these three are satisfied, then the beam is in static equilibrium. So let's go ahead and use these three to solve this problem. The first I'm going to start with is the moments formula. The reason I chose this one is because I can place my finger over one of the points and eliminate one unknown to solve for the other. So let's go ahead and put my finger on point left, and I'm going to solve this using the rest. So remember that a moment is equal to force times distance perpendicular to the point. So the sum of the moments about point left must equal 0, which is equal to, now let's do the clockwise ones first. So I'm going to have 890 newtons times the total distance away is 4.5 meters. Then I got to subtract the counterclockwise ones. So I'm going to have force right times 1.5 meters. So let's resolve that. So 890 times 4.5. We have 4,005 Newton meters. Take force right times 1.5 meters. Flip that to the other side. 1.5 meters times force right is equal to 4,005 Newton meters. Divide by 1.5. See the units cancel out for meters, and force right is equal to 4,005 divided by 1.5. So 2,670 newtons, or 2.67 kilonewtons. Okay, let's solve for the left now. So next up we're going to use this, the sum of the forces in the y direction equals 0. So the sum of the forces in the y direction must equal 0. Now we know force right was 2,670 newtons. So obviously the only one left to solve is force left. So now we're going to do all the vertical forces going up, taking the vertical forces going down. So let's do 2,670 newtons going up, take force left, and 890 newtons going down. So let's solve that. So we get 2,670 newtons, take, so let's take FL, take 890 newtons. So let's flip some of these to the other side. So we have force left is equal to 2,670 take 890, 1,780 newtons. So force left is 1,780 newtons. Notice it's going in the downward direction. Now if my answer here became a negative, then it means that I've got my arrowhead in the wrong direction. So that's how you solve and find the reaction forces on this simple beam here. Now notice this is an overhanging beam. It's not a cantilever beam.